we want to graph y equals 2x squared plus 6x plus 2. First thing we got to do is recognize this is a quadratic. It's a quadratic function, or quadratic equation. It's a quadratic function. Okay? Now, how do we graph a quadratic function? Well, we know that the zeros are given by x equals negative b plus or minus the square root of 4ac minus b squared minus 4ac, all that divided by 2a. The vertex is at x equals negative b over 2a, which I've repeatedly said is halfway between the two zeros, provided you actually have two zeros. Of course, you might not get anything here because this discriminant might be negative, and you can't take the square root of a negative is not a real number, so you might only get 1 0, or you might get no zeros out of this. You can also get just 1 0 if this discriminant happens to be 0. In any case, the vertex is at x equals negative b over 2a. And the other characteristic is if you move 1 unit to the right or left of the vertex, you're going to have to move up 2 units because of the 2 in front of the x squared. This function is a transformed function. It can be transformed by vertical stretch and horizontal and vertical shifts from the graph of y equals x squared. Another thing that's worth understanding. Okay, so, well, in this case, excuse me, we can calculate the zeros. B is 6, so x is negative 6. Plus or minus the square root of b squared, well, that's going to be 6 squared. And minus 4ac, a is 2, c is 2. And divide all that by 2a, which is 2 times 2, and we get negative 6 plus or minus the square root of, okay, 6 squared is 36, 4 times 2 times 2 is 16, so that's going to be square root of 20 over 4, and we simplify that. We could in fact write that as negative 3 halves plus or minus, okay, well, the square root of 20, 20 is 4 times 5, 4 is a perfect square. We can take the square root of the 4. It's going to be the square root of 4 times the square root of 5. Square root of 4 is 2. So we're going to have 2 times the square root of 5. Okay, the square root of 20 is 2 times the square root of 5. And if we divide that by 4, we get the square root of 5 over 2. So there are our zeros. And the vertex is at negative b over 2a. Negative b would be negative 6, 2a would be 4. That's going to give you negative 6 over 4, negative 3 halves. And that, of course, agrees with what you would get from the quadratic formula, because if we just take these parts of the quadratic formula, this is what we get. Now, we want to construct the graph. You should pause and construct that graph. Okay, well, here's a graph, and I've already sketched the vertical line x equals negative 3 halves. The vertex is going to lie on this line. So y is going to be 2x squared plus 6x plus 2, which is 2 times 3 halves squared plus 6 times 3 halves plus 2. 3 halves squared is 9/4. 2 times that is 9 halves. This is 18 halves, so that gets us up to 27 halves. And 2 is 4 halves, so that'd be 31 over 2. So that y is 31 over 2. The vertex, x is negative 3 halves, so I kind of messed that up. Okay, so let's see, that's still going to be 9 halves. That's going to be minus 18 halves, which is negative, added to the 9 halves gives you negative 9 halves, plus 4 halves is negative 5 halves. Okay, so by substituting the x-coordinate of the vertex, doing the arithmetic, you get the coordinate, the y-coordinate of the vertex, and we can now put that on the graph. If this is negative 1, negative 2, negative 5 halves is negative 2.5, that would be about here. So there's the vertex at negative 3 halves, negative 5 halves. Okay, and now we can sketch the zeros. 5, square root of 5 is a little over 2, so square root of 5 divided by 2 is going to be a little over 1. Square root of 5 is actually a little more than 2.2, I think it's 2.23 roughly. So we guess that's about a little over 1. So negative 3 halves plus a number that's a little over 1 is going to put us between 0 and 1, a little past the halfway point. And you could figure that out numerically, but it's fairly easy to locate that point. Okay, so we have the zeros here, and we have another one here. It's negative 3 halves minus the square root of 5 over 2, negative 3 halves plus the square root of 5 over 2. From this, you can sketch the graph pretty effectively. We can also see that the y-intercept occurs when x equals 0. That's going to be at y equals 2 times 0 squared plus 6 times 0 plus 2 equals 2. So we have a y-intercept here. Oh, that seems to work pretty well together. If we draw a parabola through these 3 points, very plausible it could go through this point up here. So we can proceed to sketch a pretty good graph of our quadratic function.